Anyway, we'll move on to our speaker here, and it's I'll introduce our day chair today, which is Julie Grape, very own Julie Grape. Julie has been a member of Minneapolis City of Lakes Rotary Club since 2005, where she has held various positions, including program chair, secretary, and president. She has also been active on the district level and is honored to be the current District 5950 district governor-elect coming up here. And she is installed in June, so next year. Julie loves being a Rotarian because it gives her the opportunity to serve others, build lasting friendships, and make a difference in the world. Julie has several decades of human resource and legal experience working for Fortune 100 companies, large law firms, and as an in-house counsel for a large nonprofit benefits board. In 2019, Julie decided to open her own firm so she could provide best-in-class legal counsel to small and medium-sized companies and nonprofits, assisting them with employment, corporate, board governance, employee benefits, and other legal issues. Please welcome our very own Julie Grape.
Thanks, Ross. I thought I skinnied down my bio, but when you hear people read it, you're like, oh, I need to make that even shorter. So I am pleased to be able to introduce our speaker, Justin Grammens, today. Justin is a lifelong learner and passionate about how the intersection of the Internet of Things and artificial intelligence will impact our lives. He's the founder and CEO of Lab 651, where his team helps companies quickly and efficiently build their custom software applications by providing the talent and the process to ensure they succeed. He's the owner of Recursive Awesome, where his team applies artificial intelligence and machine learning to solve their most difficult business challenges. He's the owner of IoT Weekly News, a co-founder of Applied AI and Captivation, the host of the Conversations on Applied AI podcast, and an adjunct professor at the University of St. Thomas and their graduate programs in software. A proven leader and builder of technology, Justin speaks regularly at meetings, conferences, and on Lab 651 and the Applied AI YouTube channels. Grammens was named one of the Real Power 50 by Minnesota Business Magazine and co-launched Minnesota's first Internet of Things Hack Day, where inventors compete to build the best internet-enabled product in 12 hours. He also launched the first ever artificial intelligence conference in Minnesota. Justin's a mentor to students of all ages through Coder Dojo Twin Cities and Macalester College's Mac startup programs. Most importantly, Justin is blessed to have a loving wife and two amazing boys who are the light of his life. Justin, we're so happy you could join us. Welcome.
Yeah, thank you so much. Can everyone see my screen?
Yes, we can.
Just the presentation, not all of my little side notes?
That's right.
Perfect. Good. Well, thank you so much. I appreciate the introduction. Joelle, I like you, I guess, once it's been read back to me, there's a lot of stuff in there. And I do have one slide just kind of on myself. I will gloss over that pretty quickly since you've covered most of it. But thank you so much for the Minneapolis City of Lakes Rotary Club for inviting me. I actually spoke at the University of St. Thomas a number of months ago, and a woman named Ellen Archibald connected me with the organizers. So thank you to her. And thank you for me having the opportunity to talk about computer vision. And we'll talk a little about the current and future of technology and work. So I'd like to start out with an interesting stat, right? So computer vision is being used to detect lung cancer with a 94.4% accuracy. That is pretty amazing to me. And if you actually think back to humans, human doctors are actually doing it only about 84% of the time. So using computer vision and this new technology, which I will be talking about today, we're actually saving lives. We're saving a lot of lives. With a 10.4% accuracy improvement, it is phenomenal to see this new technology, and it's just going to get better and better over time. So what's in store for us today? I've got about, I think about 20 minutes or so. I'm going to talk just briefly, one slide about who I am, talk a little bit about the subfields of artificial intelligence. We're going to focus today on this concept that you probably have heard about called computer vision, but this area where computers are learning to see and understand what's going on in the world. I want to talk a little bit about not only sort of the high level of what computer vision is, but I want to touch a little bit about how it works. So you can leave here maybe armed with a little bit more details with regards to what's going on under the covers. And then I've got a slide sort of at the end where I'll wrap it up, talk about future of work, and I'm looking forward to other people's inputs, ideas or thoughts or questions. So as we talked about, I'm Justin Grammens. I have a company called Lab 651 where we do custom software development. We help companies release their software to the market with a proven process and our talented team. I also have a company called Recursive Awesome where we do a lot of this stuff in machine learning and AI. I have a podcast and I'm a professor, and I also have this 501c3 nonprofit that I did want to mention. We have a conference coming up, and I will have a link at the end of this presentation, QR code that you can scan, and also a URL that you can go to our conference that's coming up on May 12th. And it's going to be all about artificial intelligence. It's going to be awesome. So hopefully some of you are interested in attending that. So think about artificial intelligence. There's actually a number of subfields, and I'm going to talk about the big three. I'm going to mention the big three today. We're going to dive into computer vision, but there's this whole idea of natural language processing. And I like to talk about that with teaching computers how to read and write. You might have heard about this new thing called ChatGPT, where it can be more conversational. Those are applications of natural language processing. You've got computer vision, where I like to say computers can now see, right? So these are using digital images and starting to understand what's going on in the world today. And I'm going to give really kind of concrete examples of how computer vision is being done in a number of different industries. And then you might have heard this concept called machine learning, which I believe is actually used across all of these, but it's this idea of not explicitly programming computers anymore. And I'll talk a little bit about how machine learning works as well. Now, you probably have heard of robotics and expert systems and cognitive computing. There's a lot of other things that sort of fall under here, but you know, I like to break it up in sort of these three categories. And I'm going to talk about, you know, I mentioned earlier about some examples of computer vision. We'll be talking about self-driving cars and trucks. That's always like a big thing that's going on these days in like the transportation industry, and Tesla releasing self-driving cars. We've got a lot of interest and a lot of products being bought in smart homes, right? Smart doorbells or smart cameras, right? There's a lot of interesting things that happen there that are using computer vision systems and being able to tie the whole system together. So I'll talk a little bit about examples of that. And then industrial applications. We see a lot of businesses actually have been using this for many, many years to spot defects that are going on, to optimize their lines and materials that need to come in and during the manufacturing process and safety rules. So I'll talk a little bit about that as well. So those are the three areas that we're gonna talk about today. However, I challenge people to say the most widely used application of computer vision is actually right under your nose today. And if anybody has any thoughts, certainly give them to me. What might be something that is widely used that is using computer vision? You probably use it every day. I'll give you a hint. It's right in your pocket, actually. So Face ID. If anyone uses their phone to unlock their face to unlock their phones, Apple has Face ID. Google has Face Unlock. This is a pure application of computer vision, right? And when somebody says to you, what did you learn today at the Rotary Club? You can say, I learned that computer vision is all around us. And anytime you actually use your phone to unlock, or your face to unlock your phone, you're using an application of computer vision. So while it seems like a really weird term, oh, how's computer vision being applied? It's actually being applied all over us, and people are going to continue to use it more and more. So there's something that's in your pocket, as one example. Talk a little bit about these three categories that I was talking about: self-driving cars and trucks. And you know, I like to kind of bring data into these conversations here. You know, Google started a company called Waymo, and they have actually driven over 20 million miles on public roads, and as well as 20 billion miles in simulation. So there's a lot of data that has already been captured. And why are they doing this? Well, that speaks to my second bullet point here. The American Truckers Association says there's going to be a shortage of 160,000 drivers by 2030. And these are jobs that, while might be paying enough, they're actually not going to sustain the amount of demand that's happening. This technology actually needs to be put into implementation to make sure that all of our supply chain systems and all of our delivery mechanisms actually can support the shortage that is going to be happening. And I think if you talk to a lot of truckers, you'll see a lot of stuff in the news, but what I've read a lot is that they want to focus more on the high value type stuff and not have to sit there and drive the 300, 400 mile routes. And so Google and a lot of these companies, TrueSimple, Aurora, these are companies that have invested hundreds of millions and billions of dollars into actually making self-driving trucks. And they're already driving these hundreds and hundreds of miles deliveries. Now they're in the warm states, right? They're not dealing with the snowstorm that we have, you know, today, but it's going to come. It's going to get better, but they've already proven that this is actually happening. Now, these 300-mile deliveries that I'm talking about here, there is a human there, and they do take over on occasion where needed, especially when they actually have to navigate side streets. So it's not fully autonomous all the way end to end, but from the edge of the city to the edge of the city, fully autonomous, right? And there's still questions around our society. I think if you're driving down the freeway and you look over, you don't see anybody in the truck next to you that is barreling down the road. I think there is definitely a public conscience that needs to basically be brought into place. And the other thing that's going on right now is there's a lot of liability laws that actually haven't been fully fleshed out. So you're seeing the technology evolving very, very fast. And I've seen this as I've been in this space for, in engineering and software development and stuff for 25 years. It's going to take some time for the public to actually accept what's going on, and it's going to take a little while for our government and laws to catch up. But mind you, this is definitely on its way, and you're going to see more and more of this in the future. That's basically, and I would say, the logistics or the delivery space. Let's focus on the home now, right? And I actually have one of these doorbells. I've actually found it to be really amazing. It's been a really nice way for me to see when my kids come home from school, to see when packages are delivered. And the data here is in 2022 there were 5 million video doorbells sold. And there might be some reasons around burglary and crime, but there's also a lot of interesting stuff around convenience and personalization. And this is a component of this whole idea of a smart home. You might be able to walk through your home and you could have the lights dim to certain things because it knows who you are. Music can turn on, right? There is this idea that is still being developed, and a lot of homes are becoming more and more intelligent these days that are using smart cameras. And facial recognition is being, deployed in airports today. If you go, you'll see a number of these different systems. I'll tell you a little personal story about me. I went to Canada last summer, and I didn't meet with a border agent until the very end. I actually walked up to this kiosk, and they've written up lots of reports about this. And this camera came down, and it took a picture of me and my wife and my kids, ran it through the database, made sure that it checked all sorts of things that a human would have done. And then, made sure that we weren't on all these lists, but also made sure that it matched our passport. All that sort of information was completely done through a kiosk. And then I walked up to a border agent at the end and did this final check. Now that's one step closer to eventually there won't be a border agent anymore, right? They're already talking about using apps on your phone to be able to do all this stuff. So it's definitely coming these days. And a lot of these, what I'm going to talk about here about computer vision and just AI in general, it's these mundane jobs that people are continuously doing that are not very well paid, that are actually error prone, that are actually ripe for using cameras to do that. There are questions with regards to where is this data going. And I think that is, again, I'll bring back in the concept of laws. And you might have even heard that like TikTok cannot be installed on government issued phones. They're absolutely not allowing that because it's owned by a Chinese subsidiary, and they're worried about, pictures and stuff, not even the humans that are in the pictures, but more of the things that are background around them being things that could be potentially used by a foreign agent. So again, rules and laws and regulations are still being worked out, but there is some really, really interesting stuff that's going on around security, not only at airports, but also in people's homes. And the last topic or category I want to talk about here is about industrial applications. And this has actually been going on for quite some time. I don't know if people have kind of realized this, but quality control, using to inspect everything that comes off of lines, from cars to TVs to bottling facilities. There's basically cameras that are all there that are being used to inspect for defects and scratches and dents. There are things that I mentioned earlier on around assembly line optimizations. So as manufacturers are happening, they're taking pictures and watching video and seeing too much product is coming into one spot. Let's slow that down. That's something that a human would never be able to do, be able to watch all of this stuff simultaneously and be able to do that type of stuff. Predictive maintenance is huge. In this example here, we see something's happening with regards to regular filling, happening. Well, potentially that filler spout could be actually on its way to failure, right? And so companies use this data to realize, let's go in and fix that thing before it goes down and completely breaks, and then our facility is down for a number of hours or whatever, even days. So they can jump ahead and figure out, do predictive maintenance algorithms on that. And then the interesting one is safety. And at our conference that I alluded to earlier, we had one back in November, and we had somebody from Microsoft come in, and they were working with a company that is doing oil production, right? So a big petroleum company. And as people are walking around, at these wells, they need to be wearing helmets. And so Microsoft is actually deploying computer vision systems in there to make sure that people are wearing hard hats where they're supposed to, and not where they don't have to, right? And this is something that, yeah, sure, somebody could sit at a security camera all day to try and do that, but it's just not possible for a human, or even, useful for them to do that. And I'll share another little personal anecdote. We work with a company who actually manufactures leather. And so there's a grading scheme, and they actually have humans that go through and take a look at this leather and realize kind of gets graded from an A to an F. And A grade leather is something that might end up on a couch, for example, or in a car seat. But an F or a D, those are things, it's okay. It just might go on the inside of a shoe, something you don't really ever see. So humans are sitting here doing all of this grading, which is, it's error prone, it's backbreaking work, it's stuff that nobody really wants to do. And so we help them employ or deploy a computer vision system that does all of those essentially grading mechanisms. So really, really cool industrial applications that have been going on, and they're just going to get better and better. So in sort of the last half of this talk here, I want to talk a little bit about how does this all work. And I talked about AI. So you've got artificial intelligence at this broad level, which has basically been around since the 60s. The idea of having behavioral patterns that, that can mimic what humans do. Inside of that is something that has really caught on over the past 10 to 15 years, which is this idea of machine learning. And it's a technique where machines can actually start learning all the associations between data that it's given and then outputs that happen. And then inside of that is deep learning. And this is the technique that is kind of inspired by the way the human brain works. If you hear people talk about neural networks or deep neural networks, that's this little kind of tiny subset called deep learning, which has really been popular over the past 5 or 6 years or so. And that's where a lot of the faster computer processing has been able to happen. We've been able to get, now with all this data and been able to run it through these deep learning algorithms, now we can start learning a lot more. And what has happened and what has changed and what I've seen since I've been programming since the 90s is the traditional programming model. When I was kind of got out of school, and the stuff that I learned was you were kind of giving rules and data, and you'd sit there and write, if then else conditions, based on the data that I was given and the answers that were provided, or the information I was provided, I would go ahead and kick out answers. Well, machine learning really flipped that on its entire head. And we'll talk a little bit about some machine learning techniques, and I'll show some examples of that. But you give it data, you give it the output, and you give it the information that it was sent on the way in, and the machine actually figures out the rules. And so there's no way that you'd be able to do some of these systems, any of these systems that I talked about actually, where a human could actually sit there and program this. I'm telling you, as a software engineer, you would never be able to do this with traditional programming techniques. So that's really what has changed over the past couple of decades. And machine learning breaks down into sort of 3 different areas. You've got this area of supervised learning, which is where humans come in and label things. You've got unsupervised learning, where you're throwing a lot of data at the wall and then letting the computer sort of cluster it. And then you have this kind of interesting new concept, and it's actually being used. I'll give a prime example where it's being used, but this idea of reinforcement learning, where the computer tries things, and then based on the outputs, things that you do or don't want to have happen, it either gets a reward or basically not a reward for its actions, right? So a penalty is what I should say. So I'll talk real quickly about these 3. Supervised learning. This is an example where you give the computer a bunch of pictures of apples, and a human has actually gone in there and said, this is an apple, this is a strawberry, this is a cat, this is a dog. Prime example, kind of flip back a couple slides. The people wearing the hard hats, this is an example of supervised learning. Somebody went in there and took a look at people wearing hard hats, classified them in one way, or somebody not wearing hard hats, classified them in a different way. And the machine learning model now sees a picture of something it hasn't seen before, and it puts them into one of those 2 categories, right? So it's a prime example of a supervised learning technique. And this is very powerful once you get a lot of data and you have a lot of people being able to classify that data. Unsupervised learning is a little bit of a different animal, and it's used in a different way, but it's the same concept. You throw a bunch of data into there, and the computer starts to look and say, I don't know what this is. It has no idea what an apple is, or what an orange is, or what a strawberry is, but it starts pulling out features. And then, a human can go back in and say, these are apples. If they look similar to this, these are apples, or these are strawberries. And so an example of that would be anomaly detection. So you go to the store and you buy something with your Visa card, right? Specifically in like retail, and the card company needs to make a decision. You know, is that fraud or is that not fraud, right? And I can tell you, there is no way a human could sit there and program all of those things to say, is it Justin at Best Buy, you know, in Minnesota on this day of the month with this purchase? Like, those are too many variables. There are just too many variables that happen in that thing. And so what happens is they feed this through an algorithm, and the algorithm starts to cluster where I do all my purchases, or where you might do all your purchases over time. And sure, things are going to fall out of that norm. And there are certain bounding boxes that are created to say, no, that's okay, we're not going to alert the person or not. But if you get something that's way out here, then that's fraud detection. But this idea of using unsupervised learning is something that was revolutionary for companies that are doing anomaly detection, because there's just no way you could code for all these different rules. The other thing that's really cool about unsupervised learning that I'll touch on briefly is you might have seen artwork that's generated by artificial intelligence, right? There are systems out there where you can type in penguin wearing ski goggles flying through space, and you'll get like literally a painting of a penguin doing all those things. What's cool about this unsupervised learning is it knows how to draw and it knows what those things are. But when you start to create and give it things that are outside of those bounds, you can actually use this to generate artwork, to generate music, to generate poetry, new things that actually pull in aspects of all of those other areas. So unsupervised learning is really, really powerful when you actually want to do a lot of this generative things, where you want to generate something new that maybe hasn't been seen before, but it's based on data that is known in certain categories. And the last thing I'll touch on real briefly here is reinforcement learning. This was actually taken from the Wikipedia page. This is sort of how it's like defined, but you have this agent, and let's focus on self-driving cars because this is the best application that I have for this. The agent is the car, right? And so in this particular case, the agent performs a series of actions, and the action that it does is it turns the steering wheel, right? The car can turn the steering wheel, it can apply gas, or it can apply brake. That's pretty much the actions that happen. And things that happen in the environment are just what happened in the world around it. And what the interpreter does, the interpreter says, did you run into a car? Or did you hit a pedestrian? Or are you following too close to this other car? And it either gives it a reward, or as I was talking about, a punishment, and it needs to adjust. And all this happens sort of in real time. And then it adjusts in real time what it should be its next action through. So when I talked earlier about, you know, we've got 20 million miles that have been driven. Those are actually miles that are on the road. But when I said 20 billion miles driven in virtual simulations, that's what's happening here, is you're basically training it on video of cars driving in a simulated environment, and you can run these through. You can run this system over and over and over again for billions and billions of miles, and the computer can start to get smarter and smarter with regards to how it should apply the brake or how it should turn the wheel to avoid all of these things, and you keep giving it rewards. So it's getting better and better over time without actually having to drive more on the road. So my last slide here, and I wanted to just sort of sum up with regards to what we touched on around, you know, the future of work. And there's lots of ideas around, you know, how this is going to impact the person sitting in the seat. But I believe all of this is a net positive, right? We've talked a little bit about healthcare, image analysis that can happen. You know, it can help with cancer. There are just countless of other areas where it's being applied in healthcare today. From early diagnosis, there's companies that are taking a look at people's retinas and figuring out what diseases they have based on certain colors that are happening inside their retinas. Just amazing stuff. Security, you know, smart doorbells, facial detection going on. We've got, I didn't really talk about that, but many of these doorbells, if somebody that you know walks up to the door and you recognizes the face, it will either alert you on your phone because it's somebody you know, or alert you somebody you don't know, for example. And then there's also smart locks that'll connect to your lock and will unlock the door based on a face that it recognizes. We talked a little bit about manufacturing, right? So maintenance and safety and efficiency. I mean, a lot of that is just making these manufacturing plants just more and more efficient and taking out a lot of the mundane jobs that people really don't want to do. Transportation, self-driving cars. We actually work with a company, very interesting. They have a dash cam, and this is for semis and trucks, sort of fleet drivers. And this camera will actually, it has a camera facing forward, so it's watching with regards to what they're driving, but it also has a camera facing backward at the driver, and it will recognize if they're falling asleep. It will recognize if they're distracted. It will recognize if their eyes are on the road or looking left or right. So those are, and then it will alert, right? So these are things that are being built more and more around really awesome use cases around safety in the transportation sector. And one last area I didn't really touch on, but I did want to mention here is this idea of OCR, and it's optical character recognition. And you might have a company that has a lot of papers, and we actually had a person present from US Bank at our last Applied AI conference, and he talked about all these forms that happen during a mortgage loan process. And so how are you supposed to be able to intake all of this? Or let's say you're a legal firm doing discovery and you have to go through 1,000 documents. This is where computer vision is key. They're scanning through all these documents, changing it into digital form, and then you can start running all of the smarts and the models, the learning models over it to find the things that you want. So OCR is super powerful, and that's another strong area where we're seeing a lot of, again, mundane work that's being transformed with regards to, the use of computer vision. So that is sort of what I wanted to talk about today. I am very interested in hearing people's thoughts, or if they have any questions or answers, or any questions, hopefully I can provide answers, or we can solve them together as a team. Interested in staying connected. So I mentioned the Applied AI conference, and if you get out your phone and use computer vision on your phone, scan this QR code, or just go to appliedaiconf.com. We'll be having our second conference here on May 12th. It's going to be happening at a place called Basecamp out by the airport. And it's just a really, really awesome event. We did one in the fall, and it spans all sorts of areas. So if you're interested in any aspect of artificial intelligence, computer vision is just one piece. I touched on a lot of other stuff here, but AI is just such an amazing area. Please attend appliedaiconf.com. And thank you so much for the opportunity, and I'm open to taking questions. Here's my information at the end. If you want to reach out to me, here's my email address and our company.
Great. Thank you, Justin. Are you willing to stick around after?
Absolutely. Yep.
Yeah, for questions. I know some of our members may have some questions. There's always concerns about, this taking away jobs. So that's maybe a question that we could talk about. But
Sure.
I wanted to maybe close here and let some other people go if they have other hard stops. But so in honor of you speaking here today, though, Justin, if we were in person, we'd have you sign a book that we donate to Way to Grow. It's a nonprofit that helps at-risk students in Minneapolis to be more successful in school. And that's given to a third grader, signed by a leader of our community like you. We also have a pen with your name on it. Unfortunately, it's at the Women's Club, so that would be yours to keep. So we'll get that to you as soon as we can. So thanks for joining us today, Justin, and speaking. I also wanted to thank our volunteers for today. Our greeter, Alex, very nice to see you again. Awesome to see you. Reflection by Kurt Nelson, Vocational, Mark Lavovitz, the Fruit Basket. Thanks, Jean, for facilitating that. Our day chair, Julie Grape, our Zoom master, Brock, and club admin, Steve and Dick. I'm not sure if they're online, but thanks for their support. Next week, March 1st, we hopefully will be back in person. I don't see any forecasted snowmageddons, but I'll be giving our state of the club. March 8th, Jeff Olson, one of the Minnesota hockey greats, will be talking about homegrown talent in the NHL. And then the 15th, we have a Courageous Conversations talking about auto theft in Minnesota. So with that, be safe today and tomorrow. Go out and have a wonderful Rotary week. Thanks, everyone.